Hello everyone and welcome to Noob Engineering. I am here to teach you the last year mechanical engineering subject, that is HVAC and dynamic of machinery. I am going to teach you exactly what you need to know. I will also provide you with essential notes and important questions that may come up in exams. And my goal is not just to help you pass exams but also to ensure you that you truly grasp the fundamentals of HVAC. But I can't do this alone. I need you to be an active part of our growing noob engineering community. So don't forget to hit that subscribe button and turn on the notifications so that you may get all the notes and important questions and our videos on time. Okay, let's start our first lesson of our first unit of HVAC, that is practical aspects of vapor compression and advanced refrigeration systems. So, in this session, I will explain you the introduction to the unit 3, that is practical aspects of vapor compression and advanced refrigeration systems. In that it is divided into three chapters. That is, first one is major components of refrigeration cycle. In that there are the types of compressors, means compressors are there, evaporators are there, condensers are there, and true expansion walls are there. So these are the components that are in vapor compression cycle. So this is one chapter. Then the second chapter is safety controls. In safety controls, there are LP or HP cutoff, that is low temperature control, for frost control, motor overload control, oil pressure failure control, capacity control for different compressors. Okay, these are the safety features for a compressor that we also have to learn. And at the last, there is advanced refrigeration system, that is transcritical cycle, and their types. Simple ejector refrigeration system. This last chapter is only based on analysis and numericals. So without wasting our time, we should go on our first chapter. And the first thing is, what is a compressor? It is the biggest thing to start this unit 3, to know what is a compressor first. A compressor is a mechanical device that increases the pressure of a gas or air by reducing its volume. It does this by trapping a certain amount of gas in a confined space and then reducing the space volume, which results in an increase in pressure and temperature as well. Okay. Compressors are used in various applications, indulging refrigeration, air conditioning, industrial process, and pneumatic tools to pressurize and transport gases from specific purpose. They come in different types, such as reciprocating, rotary, and centrifugal compressors, each situated for various needs and requirements. So, this is the definition, you can say, or the explanation of a compressor, or what is a compressor. So, you can write this in an exam, or I will tell you one simple explanation. You have seen this compressor, okay, right? See this one. You're seeing on my, yeah, this one. This compressor you can see everywhere. Means everywhere means you can see this in you go for a car wash or you go for a bike wash. You can see this compressor. Yes, you can see this compressor. But what is a compressor? A compressor does a work to increase the pressure and temperature. Pass this much only it has to do. It just compresses the given refrigerant, that might be liquid refrigerant, that might be vapor refrigerant, or any type of refrigerant. Okay. Uh, though the compressor compresses the given refrigerant and increases pressure and temperature. Simple. बाकी कुछ नहीं है, इतना ही है. So let's move on. You understand what is a compressor. Then move on. What are the types of compressors? Uh, but before going, we can see here the word this last line. They are different. They come in different types of different types such as reciprocating, rotary, and centrifugal compressors. In our syllabus, we have to study only reciprocating and centrifugal. Okay, we are not going to rotary one. So let's start. Types of compressors. Okay, there are they differentiate in in twos that are positive displacement compressor and dynamic displacement compressor. And in positive displacement compressor, there is a reciprocating compressor, and again it's divided into four parts, that is single acting, double acting, single stage, and multi-stage compressors. And in dynamic displacement compressor, it is divided. It has further only a centrifugal compressor. So without wasting time, we should move on to the reciprocating compressors. Okay, but first, what is the positive displacement? A positive displacement compressor is a machine that compresses gas by reducing its volume through the fixed of through the use of fixed or moving parts. It operates by trapping and displacing a fixed amount of gas with each cycle, resulting in high pressure. Okay, it's a simple definition of a compressor. You don't need to concentrate on this. Okay, this we should know. If you want, you can write it in exam. So, what is a reciprocating compressor? A reciprocating compressor is a type of positive displacement compressor that uses a piston moving back and forth inside a cylinder to compress gas. It draws in gas on one stroke and compresses it on the other stroke. Okay. Uh, it has four types of we discussed it in the last slides. It has four types, that is single acting compressor, double acting compressor, single stage compressor, and multi stage compressor. Okay, so let's start with the first one, single acting compressor. So why are we learning this? So in the exams they will ask, draw a PV diagram of single acting compressor and explain it. Okay, or they may ask, explain the types of compressors and draw PV diagram of single acting compressors. Okay, so mainly the questions will come on single acting and no, sorry, the mainly questions will come on single stage compressor and multi stage compressors. Okay, now first we have to study and understand what is a single acting compressor. So a single acting compressor is a type of reciprocating compressor that compresses gas using only one side of the piston. In a single acting compressor, gas is drawn into the cylinder on one side of the piston during the intake stroke, and then the piston compresses the gas on the opposite side during the compression stroke. This type of compressor is typically used for low pressure applications and is less efficient than double acting compressor, which compresses gas on both sides of the piston. Single acting compressors are often found in smaller portable air compressors and refrigeration systems. The steps are given below: intake stroke, compression stroke, discharge stroke, and exhaust stroke. So, what is a single acting compressor? I अभी मैंने पढ़ के दिखाया इतना तो समझ में तो नहीं आया होगा. So let's us understand by seeing a diagram. So this is a diagram of single acting compressor. In the single acting compressor, we can see here is one piston. Wait a minute. This is one piston, crankshaft. We call this as chamber, and this is the clearance space. This is a suction valve. This is a discharge valve. So now what happens here? The suction valve sucks the refrigerants in. After that, the pistons move back. See this one. By moving back, the refrigerant travels inside. After it travels inside, it the piston reaches the bottom-led center. After reaching, it moves upward once again by, but this time it compresses this. See, assume it as a refrigerant. It compresses this refrigerant. Okay, it compresses this refrigerant, and you can see here by compressing the volume decreases. You can see here, the volume decreases, and after the volume in decrease in the volume, the pressure and the temperature both increases, and this is one discharge. Okay, now tell me what increases and what decreases. I will write here pressure, temperature, and volume. Now tell what increases and what decreases. If you are telling pressure increases, then you are right. If you are telling the temperature decreases, then also you are right. But the volume increases or decreases? The volume decreases. Okay, now this is the PV diagram which would ask you in exam. Okay, 1 minute. Okay. It's simple to draw. On x-axis you may write volume, and on y-axis you may write pressure, and this is the volume line. This is also volume line, and this is the pressure line. Okay, now the first thing, why this volume is increasing? Because it is an suction stroke. Okay, in suction stroke the volume increases. After that the volume is slowly decreasing with an increase in pressure. What happens here? Here volume increases, but here in compression curve the volume the volume decreases with increase in pressure. Okay, and after that at the delivery wall you can see there is a decrease in pressure, sorry, decrease in volume, but at a constant pressure. Okay, clear? See this line, volume decreases with pressure constant. Okay, this is about the single acting compressor. If you have any doubts, comment down. I will surely give you the answer. So let's come towards the second one, that is double acting compressor. So what is a double acting compressor? Now you saw in last slide a diagram of single acting compressor. What did you saw or see? You saw one piston, one crankshaft, and they were moving back and forth, back and forth. Okay, this is single acting, means only one reciprocating part is available in the compressor. In double acting compressor, it uses both sides of piston. In double acting compressor, gas is drawn in the cylinder on one side of the piston during the intake stroke, while simultaneously compressing gases on the opposite sides during the compression stroke. It means that the piston available in the compressor, when it goes to top dead center, it compresses. When it comes to the bottom dead center, then also it compresses. So that's why it is called as double acting compressor. Okay, the step in this processes of double acting compressors operations are as followed. First one is intake stroke, that is on both sides. Compression stroke, that is also on both sides. Discharge stroke, that is also on both sides. Then exhaust stroke, that is also on both sides. Why I'm saying it on the both sides, because the process is same even if it is being at a different timing. Okay, let's see the diagram. This is a diagram of double acting compressor. You can see a piston and two inlet valves and two outlet valves. Okay, by seeing this diagram you may not understand anything, so keep this picture in front of you, and I'm going to play a video of double acting compressor to clear how does it works. Okay, now let's move on to the video. See, now you can see here the double acting compressor. Okay, this is an intake side and this is outlet side. Okay, now this is an intake part of first and this is outlet part of first. This is the intake part of second and this is also the outlet part of second. Now the refrigerant comes here and goes out from here. Okay, and similarly the refrigerant comes in here and goes out from here. This is a piston moving back and forth, compressing the compressing the refrigerants. Okay, now wait, this is the PV diagram of double acting compressors. Now what do you understand by this? There are two graphs drawn in it. Okay, the first one we will go with the blue one. Okay, this part, this, and this is one, and this is the red part. We will denote it by green one. Wait, this is the second part. This diagram you have to draw it in exam. If asked, the pressure and volume diagram for a double acting compressor. It's simple, as we have to draw only two diagrams here. See, as we discussed, first one is suction, second one is compression, third one is discharge, that is constant pressure with decrease in volume, and same as it for the second part also. See here, this is 1, this is 2, this is 3, and this is 4. Okay, 1 to 2 increase in volume, 3 to 4 pressure increases with decrease in volume. Okay, and here the 3 to 4, the pressure is constant. Okay, but the volume decreases. This all thing I will provide you in the notes. No need to draw here now. Just concentrate and see the remaining video, how it works. See the volume reduction they are also telling. Okay, uh, let's move on the next part.
This is the next part. You can say the next thing, single stage compressor. Now you may say that say we learned just now only that is single acting compressor. Then what is single stage compressor? A single stage compressor is a type of compressor that compresses gas from its initial take pressure to a higher discharge pressure in a single compression stage. In other words, the compression of gas happens in one step or one set of compression components, such as a single set of rotating screws, pistons, or impellers. Now, I will tell you the difference of single acting and single stage compressors. Now, what we discussed in single acting compressors, that the moving parts which compresses the refrigerant, or the type of compression is in only one side or two side. Okay, that is single acting. And what is single stage? It describes the stages of compressions. Okay, it may done in two stage or multi-stage or single stage. Means compression of a gas in a single stage or a two stage or a multi-stage. Okay, so here are some key points of single stage compressor. One step compression, common for moderate pressure, simpler design and efficiencies. So as compared to the other one, that is it is very efficient for applications where we do not require high pressure but less suitable for very high pressure ratios. Okay, the diagram for this, now you can see the diagram of single stage compressor. It is as similar as the single acting compressor. Now the question is why? Now you can see, wait, I will show you. This is what the piston, the crankshaft, and the cylinder, and one suction stroke, one outlet stroke, and this is everything all. But by doing one rotation, how many compressions are happening? Only single. Also, single compression is happening here. Okay, here only a single compression is happening. There is no multiple compression. Okay, is it compressing when it comes down? No, it's only compressing when it goes up. That's why it is a single acting compressor, single stage compressor. So the PV diagram will also be the same. The diagram will also be the same. That's why, but the wordings are different. Understand that. Okay. Now let's move to the second part, that is multi-stage compressors. Okay. Now what is a multi-stage compressor? Now, as we discussed in the previous slides, what is a stage? A stage means the number of it is an entity to measure that the compressions. Okay, multi-stage means it it has multiple compressions. Okay, multiple compressions, multiple pistons, multiple crankshafts, and everything that requires in it. Okay, now let's see. Multiple stage compressor is a type of compressor that compresses gas in two or more separate stages or steps. Each stage has its compression components such as piston, impellers, and contributes to increasing the gas pressure. Every compressor's work is same to increase the pressure. So No need to take any load. If you don't remember anything, just say it increases the pressure, it increases the temperature, and decreases the volume. Okay, the working is same, but mm, there's a different types of compressors because of the different types of applications. Different type of applications. Okay, where everyone needs a high pressure or low pressure uh, with increasing temperature with increasing temperature. Okay, as the application changes, the compressor also changes. So this is the last compressor we are going to study in a reciprocating compressors, that is also called as positive displacement compressors. Okay, now here are some key points of multi-stage compressor, that is multiple compression stages. Multiple compression are designed with two or more compression stages. Each stage further compresses the gas, leading to higher discharge pressures. It has also high pressure ratios. It comes with intermediate cooling, and it comes with efficiency and reliability is much more higher, but comes with a complex and costly to design and to operate. They're efficient and reliable for high pressure applications where safety and precision are crucial. That okay. Let's move on to the next slide. That is diagram. Now the diagram will also be the same, so no need or anything to take any load. Okay, to learn a second diagram. So double acting compressor, the similar diagram for multi-stage compressor. Okay, just change this name when it comes in exam. Both inlet walls, outlet walls, but the compressions are two, so that's why it's a multi-stage compressor. Multi-stage. Okay, why? Because of two compressions. Okay, this is the first compression and this is the second compression. First, second. That's why it is a multi-stage compressor. And the PV diagram, I'll give it in the notes. Don't take tension. Okay. Now let's move on to the next slide or the next thing, that is dynamic displacement. We can move on to the centrifugal compressor. Dynamic displacement, no one asks. Okay. Centrifugal compressor. Centrifugal compression HVAC is a device that uses a speed rotating impeller to draw in a compressed refrigerant gases. It increases the pressure and temperature of the refrigerant, making it suitable for cooling or heating in air conditioner systems. Centrifugal compressors are efficient and commonly used in larger HVAC systems like those found in commercial buildings and industrial settings. ये तो हो गया बुक में लिखा हुआ, तो इसका एग्जांपल मैं देता हूँ आपको. Everyone have used hair dryers. Yeah. Is there any inbuilt air, or you capture air or something and give it to the what we say hair dryer? No, no. So the working of hair dryer is totally based on centrifugal compressions. Okay, let's see how. So this is the diagram of centrifugal compressor. In this centrifugal compressor, you can see the video, the casing, the air intake. This is an impeller eye. This is a impeller. This is the impeller vane. This is a driven shaft. This is diffuser vane, diffuser ring, and vault casing. Okay, these are the components of a centrifugal compressor. But the working is very simple. see here, the air intake, the air enters here. Okay. After the entering of air, the impeller rotates very fast. Okay, the impeller rotates very fast. By rotating this impeller, okay, it increases the pressure plus velocity. Okay, this time it increases the pressure and the velocity, and this is the velocity plus the temperature. Okay, the working is simple. It takes air from outside only, that is an ambient temperature air. Okay, then it rotates the impeller. After rotating the impeller, it rotates so fast that it compresses the air and increases the pressure and velocity of that air and throw it out of the compressor. Okay, this results in increase in pressure, increase in velocity, and increase in temperature. This was the last compressor that we have to study in our chapter 1. At last, I request you all who have watched this video to subscribe the channel, like the video and comment down your questions and give a feedback as it is my first video. Okay, see you in the next video. Bye and take care.